Good evening, Bearcats. This is Unit 5 review, and this is our part 2 of our review. This is over sections 2.4 and 2.5. We're going to start with simplifying and expressing in standard form these complex imaginary numbers. If you remember, our standard form is A plus BI. That's really important. A is the real part. B is the coefficient to the imaginary part. So let's get started. Okay, for A, we have this first example. We have f of x equals 3 minus 5i squared. We're going to use our binomial. When we have a shortcut for squaring binomials, we're going to use the same shortcut. Remember, what we do is we take the first term and we square it. So 3 squared would be 9. We multiply everything together. So 3 times negative 5i would be negative 15i, times 2 would be negative 30i. And then we take the last term and we square it. So negative 5i squared would be negative 5 times negative 5 is positive 25i squared. But if you remember, I squared is actually negative 1, and that's going to change our 25 to a negative. So we have a positive 9 and a negative 25, so together we have a negative 16 minus 30i. And that would be simplified for that part. All right, let's go on to part B. For B, we have f of x equals negative 2 plus 4i squared. Very similar problem, again using that same shortcut. So we take the first term, negative 2, and square it, which would be positive 4. We multiply everything together, so negative 2 times 4i is negative 8i, times 2 would be negative 16i. And then we take the last term and we square it. So 4i squared would be 4 times 4, so that's positive 16i squared. And then remember, the I squared is just going to change our 16 to in this case, a negative number. Positive 4 and a negative 16 gives us a negative 12 minus 16i, and we're in correct form on this one. All right, let's look at C. For C, we have f of x equals 3i plus 9i squared. Again, we just have this I squared that changes the 9 to a negative, and in standard form we would be negative 9 and positive or plus 3i, and we would be in standard form. Moving on to part D. For part D, we have f of x equals I to the 68th power plus I to the 335th power. All right, just a reminder for you right here. This is kind of an important reminder. Reminder that I to the first is I squared is negative 1, I cubed is negative I, and I to the fourth is 1. And then it repeats itself. So these come in fours, and in every fourth one it repeats itself. So if I to the fifth would be I to the eighth would be 1 again. So because of that reason, we can divide our exponents by 4. When we divide by 4, it'll be the remainder that gives us what value that we're looking for. So in other words, if we have I and we take 68 and we divide by 4, the remainder is going to be 0. And if the remainder is 0, that's just like having a 4, so that's going to be, because it goes in there evenly, an even amount of times. If you divide by 4, it goes in an even amount of times, so this answer right here would be 1. Then for 35, we have I, and we would take 335 divided by 4, and when we do, our remainder is going to be 3. And so we have to look at I to the third, which is negative I. So this is going to be plus negative I. So if we write this in standard form, it would be 1 minus I would be our answer. Make sure you're good on that before your test. All right, let's keep going. Alright, for E, this example, we're trying to clear our denominator. We don't want any imaginary complex numbers in the denominator. So if you remember, the little trick to clear our denominator is to multiply by its conjugate. The conjugate for 8 minus 3i would be 8 plus 3i. And then, of course, because we are fair and equal in math, we would do the same thing to the numerator, 8 plus 3i. And let's go ahead and finish this up then. Alright, in the bottom, because they're conjugates, you know what happens. We only have to multiply the first times the first, so that's 8 times 8, which is 64, and then the last times the last. So negative 3 times positive 3 would be a negative 9, and then it would be I squared. But remember, the I squared is just going to change our 9 to a positive. So all of a sudden, we have 64 plus 9, and 64 plus 9 is going to give us a 73 in the denominator. At the top, we will have to do old-fashioned FOILing. So 2 times 8 is 16, and 2 times 3i would be positive 6i, and then negative 3 times 8 would be negative 24i, and then negative 3i times positive 3i would be a negative 9i squared again, which again is going to cancel out and make the 9 positive. So all of a sudden, when we combine like terms at the top, we'll have 16 and 9, which is 25. We'll have 6i and negative 24i, which gives us a negative 18i. Then we need to simplify. So to simplify or put it in the right form, we would put 25 over 73. And then since it's a minus 18i, we'll put a minus, and we'll put 18 over 73 and the I on the outside. This puts us in A plus BI form. It's just that the B is negative this time. So there is your answer. And neither one of those can simplify to my knowledge. All right. Now we're going to multiply these complex numbers. The first thing we're going to need to do is rewrite. And we need to be able to pull that I out for the negative. So we'll rewrite it as 4 minus I square roots of 2 and 7 plus I square roots of 6. That gets rid of the negative under the radical, which is important. And then we're going to do old-fashioned FOILing. So 4 times 7 is going to give us 28. And 4i times the square root of 6 is just going to give us a positive 4i square roots of 6. And then negative I square roots of 2 times 7 is going to give us a negative 7i square roots of 2. And then finally, our negative I times our positive I is going to be a negative I squared. Square root of 2 times the square root of 6 would be the square root of 12. Now, the I squared is going to be crossed out and make this become a positive. So make sure you understood that. That crossed this out and this became a positive. We do need to simplify the square root of 12. I'm going to go over here to the side and do that. So 12 divided by 2 is 6, divided by 2 is 3. There's a pair of 2's. 2 comes outside the house, 3 stays home. So this whole thing right here becomes 2 square roots of 3. All right, now we need to put it in A plus BI form. Let's write that down. A plus BI form. All right, A, of course, is the non-imaginary parts, which would be the 28 and the 2 square roots of 3. So we're going to go in parentheses 28 plus 2 square roots of 3. That is the, oops, didn't do a very good job there. That is, let's just see if I can just, that's okay, you get that. So 28 plus 2 square roots of 3. That's the A part, plus the B part. All right, the I is going to, they share an I. The I is going to go out here on the outside. So the I is gone, and we have 4 square roots of 6 minus 7 square roots of 2. I. And that is our answer. Sorry that's so messy. So make sure that we are in the correct form. So Bearcats. Alright, this is where we start putting everything together. Here's our function f of x is equal to 2x cubed plus 7x squared plus 2x minus 3. And we're going to use our P's and Q's, our Descartes chart, our synthetic division, quadratics, and we're going to finish by solving. So here's the process. We're going to start with our P's and Q's. We're then going to go to Descartes chart. Sorry, kind of messy. Then we're going to go to synthetic division. And then we're going to go to the quadratic. And then finally we're going to finish by finding our zeros. And then we're going to graph. Alright, so this is kind of everything that we're doing. I really apologize for how messy that is. Alright, the first thing we're going to do is our P's and Q's. Our P's and Q's are our possible rational roots. That narrows things down a bit. That's going to be our factors of 3, our positive and negative factors of 3, which would be 1 and 3, over our positive and negative factors of 2, which would be 1 and 2. Therefore, our P's and Q's would be the positive values of 1, 3, 1/2, and 3/2. Okay, so that's our list. So there's 8 possible choices there. Now we're going to do Descartes' chart, and we're going to be able to tell maybe should we start with positives or negatives when we start synthetically dividing. Alright, remember how to set up our chart. We're going to have our positive values, our negative values, our complex imaginary values, and our total. And this is the types of solutions. How many positive real roots we have, how many negative real roots we have, not the actual value of the root, but the positive and negatives, how many complex we might have, and how many total. Alright, well, we know that the total will be 3 because we have a third degree polynomial. So let's go ahead and put a couple of rows in. We might have more rows, but at least we know we have 2. Alright, and then we're going to go ahead and check for our positive values. So we're going to take a look at the terms, and if the x's were positive, this term would be positive, this term would be positive, this term would be positive, and this term would be negative. And if I look through the sign changes, it's positive, 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 negative. I have 1 change. And if you have a 1, remember you go down by 1s. If you have a 0, you go down by zeros. Anything larger than 1, you decrease it by 2. So you subtract 2 each time. So you get to a 1 or a 0. Alright, for the negatives, we're going to pretend like we put a negative in for our x values. If I take a negative and cube it would be negative times a positive 2 makes the whole term negative. We take a negative and we square it, it's positive times positive 7 makes the whole term positive. We take a negative times a positive, we get a negative, and of course 3, the constant is negative. How many sign changes do we have? We have 1, negative to positive, positive to negative. Looks like we have 2 or 0. If we add straight across, that's already 3, so we'd have 0 complex, or we would have 2. So in other words, when we find our graph in the end, we should either have 1 positive real root and 2 negatives, or we should have 1 positive real root and 2 imaginary, which we wouldn't be able to actually graph, for a total, though, of 3 zeros. So let's see in a minute which one we think that might be. Alright, let's keep going. So I'm going to start with positives because I for sure have one. I could divide by all the negatives off this list and find that I don't have any. If I divide by all the positives, I'm supposed to have 1 and only 1. So as soon as I find that 1, I can stop dividing. Alright, let's go ahead and set up our synthetic division. We're going back to our original formula, and our synthetic division, we don't have any skips in our degrees, so it's going to be 2, 7, 2, and negative 3. We'll do our synthetic division. Alright, so we'll start with 1. We bring down our 2. 1 times 2 is 2. 2 and 7 is 9. 1 times 9 is 9. 9 and 2 is 11. 1 times 11 is 11. And 11 and negative 3 is 8. If you're paying attention, this is an upper bound. So 1 is your upper bound. In other words, we will have no more positive solutions on the right side of our graph. So if we have a positive solution, which we know we have 1, it's going to have to be less than 1. So maybe we need to go try one of these fractions, so we'll try 1/2. Since 1 did not give us a 0. It did give us a point, though, at 1, 8, and that'll help us in a minute when we decide to graph. All right, and remember, this is the y-intercept, 0, negative 3. All right, so the next thing we'll try is 1/2. So bring down the 2. Half of 2 is 1, 1 and 7 is 8. Half of 8 is 4, 4 and 2 is 6. Half of 6 is 3, 3 and negative 3 is 0. Hallelujah, we found a 0. So we know we have the point at 1/2, 0. That's an x-intercept. Now we also have a quadratic, which I'm going to stop synthetically dividing, and go ahead and finish finding my roots by quadratic formula. So we have 2x squared plus 8x plus 6. Or I could find it by factoring, hopefully. Alright, I notice that all of these are divisible by 2, so I'm going to factor out a 2, because since I'm solving, I can do that. X squared plus 4x plus 3. Oh, it looks like I can factor x and x, 1 and 3, plus and plus. So my solutions here are -1 and -3. Ooh, look at what we found. Our x values, our x-intercepts, our solutions, our roots are 1 positive at 0.5 or 1/2 and 2 negatives at -1 and -3. So we ended up on this part of our chart. So this kind of proves that it works. Alright, let's also go ahead and graph what we have. So we have x-intercepts at -1, at -3. We have a y-intercept at -3. We'll just say that's 1, 2, 3. And we have an x-intercept at 1/2. Alright, and we know from our original graph that it goes up on the right because it was positive, and it's a cube, so it's an odd exponent, so it's going to go down on the left. And it looks like we don't have any multiplicity, so we could go ahead and draw our graph and see right here. It looks like it would go down through here, it's going to hit that y-intercept, it's going to go up through here, and it's going to come back down. Our graph would look something like that. Alright, you are getting to be so good. Go Bearcats. Alright, I think we have one more example. Alright, the last two examples we have on part 3 of your review are about lower and upper bound. So let's go ahead and set up our lower and upper bound chart. I'm also going to give you a lot of extra information kind of as we go. It's basically synthetic division, but just we don't really worry about our P's and Q's so much when we do our lower and upper bound chart. We always start at 0, and 0 just gives us our coefficients. There is no skipped values or any degrees, so third degree, second, first, constant, so we don't have to worry about any zeros to hold for placeholders. So we would have a 2, a -5, a -5, and a -1. And we're going to synthetically divide just going straight through by whole numbers 1, 2, 3, 4 until we reach all positive values, which would be our upper band. So we're going to start with 1, and we bring down the 2. 1 times 2 is 2. 2 plus -5 would be -3. 1 times -3 is -3. -3 and -5 is -8. 1 times -8 is -8. -8 and -1 is -9. Alright, the one thing about lower and upper bound charts, you are finding points on a graph as you go. So I'm just going to go ahead and list those. Right now we know we have 0, 1, which would be your y-intercept. We have a point at 1, -9. So if we're graphing, it's kind of interesting to look at this. We have 1 at 1, -0. We have 1 at 1 way down here at -9. Let's keep going. We've not reached an upper bound. That means we will cross back over the x-axis at some point. So let's keep going. 2. We remember we're using this top row of numbers, and even when we found a 0, if it's not the upper bound, we would keep using those top numbers. That's something a little different. So you bring down the 2. 2 times 2 is 4. 4 and -5 would be -1. 2 times -1 is -2. -2 and -5 would be -7. 2 times -7 is -14. -14 and -1 would be -16. So we have that point at 2, -16. So that's going to be way down here somewhere. Alright, let's keep going. We have not found our upper bound. At 3, we bring down our 2. 2 times 3 is 6. 6 and -5 would be a 1. 1 times 3 is 3. 3 and -5 would be a -2. And 2 times -2 times 3 is -6, and -1 would be -7. Alright, well at least it's coming back up. You can see that. So at 3, you're at -7. Let's see, this was -9, so it's got to be up here a little bit. So we can tell our graph shape is coming back up. I'm going to just write the other pairs over here, 3, -7. These are just all points on our graph, but not an upper bound yet, so we still have more to go. Let's go to 4, bring down the 2. 2 times 4 is 8. 8 and -5 would be 3. 4 times 3 is 12. 12 and -5 would be 7. 4 times 7 is 28. 28 and negative 1 would be 27. Looks like we found an upper bound. So 4 is our upper bound, and our values, our point here would be at 427. So somewhere, so 4 would be way up here at 27. Somewhere between 3 and 4, we have to cross the x-axis. Let's go ahead and draw in sort of what that was going to look like so far. Somewhere in there, we would cross the x-axis. But we would never come back down again because we've reached our upper bound. All right, let's keep going. And, you know, you could keep using those top numbers. It's a long way to look. So I always like to add, I just like to recopy that row again. So 0, 2, negative 5, negative 5, negative 1. And this is for my lower bound chart. And I like to circle again, and I like to draw another line. And now I'm going to look for lower bound. Lower bound, I'm going to use negative numbers, so starting with negative 1. And I'm looking for an alternating sign pattern when I reach my lower bound. All right, so bring down the 2. Negative 1 times 2 is negative 2. Negative 2 and negative 5 would be negative 7. Negative 7 and times 1, negative 1 is positive 7, and negative 5 would be a positive 2. Negative 1 and times 2 would be negative 2. Negative 2 and negative 1 would be negative 3. I believe we are there. That was pretty quick. Positive, negative, positive, negative. We have alternating signs, so negative 1 is my lower bound. All right, that's interesting. So at negative 1, our ordered pair is at negative 1, negative 3. Negative 1, negative 3. So negative 1, negative 3. I'm not really sure without looking at it in a graphing calculator. You know, I guess we could have a multiplicity of some value between 0 and negative 1 where it touches the axis and comes back down, or the graph just comes up and then just makes this curve back down this way, and that would be because there's two complex imaginary solutions. We'd have to investigate a little bit more to tell that. All right, let's go on to B. All right, here we go in our last example for your review. Make sure that when you're in class tomorrow that you get all your questions answered. And if you're looking at this on the night, the last night, hopefully you've already got all your questions answered. I'll try to be there early on Tuesday morning, so if you have questions, then you can also get them answered. All right, here we go. So we've set up our long division for our upper and lower bounds chart. Remember, this is always a 0. And so the first point we have is our y-intercept at 0, 2. So we can go ahead and put that at 0, 2. I'm just going to count on half, so we'll just say that's about 2. And then we'll start with 1. So we start with 1, we bring down the 4. 1 times 4 is 4. 4 added to negative 6 is a negative 2. Negative 1 times negative 2 is negative 2. Negative 2 and negative 7 is a negative 9. 1 times negative 9 is a negative 9. Negative 9 and 9 is a 0. 1 times 0 is 0. 0 and 2 is 2. So we also have a point at 1, 2. That's interesting. So we have a point at 1, 2. So I'm assuming our graph probably goes up. Let's keep going. All right, let's try, but that's not an upper bound, so let's go to 2. So at 2 we have, we bring down the 4, and let's circle these. It makes it a little easier to see what we're doing. And 2 times 4 is 8. 8 and negative 6 would be a 2. And 2 times 2 is 4. 4 and negative 7 would be a negative 3. 2 times negative 3 is negative 6, and positive 9 is a positive 3. And 2 times 3 is 6, and 6 and 2 is 8. And so now we have a point at 2, 8. So at 2, we're all the way up here at 8. It's kind of interesting. Looks like it's rambling around here a little bit, kind of like that hurricane out in the on the east coast right now. You guys should be watching that. It's an interesting weather pattern. All right, sorry, back to business. Number 3. Try 3. Bring down the 4. 3 times 4 is 12. 12 and negative 6 is 6. 3 times 6 is 18. 18 and negative 7 would be 11. 3 times 11 is 33. 33 and 9 would be 42. And 3 times 42 is like 126 plus 2, which would be 128. So obviously, that is an upper bound. All those are positives. They're all positive. And so 3 is our upper bound. So at 3, we're way up here off the chart somewhere. All right, so our graph, we're not sure if it comes back down and has a 0 or not. That's kind of an interesting thing. We don't really know that for sure. We didn't find a 0 and we didn't have a sign change. So that's something interesting. There's no sign changes here, so everything stayed above the x-axis. So I'm assuming then that we're just rambling around down here somewhere. And it must look something like that. All right, let's keep going and do our lower bound. So I'm going to start over with the 0, the 4, the -6, the -7, the 9, and the 2. And we'll do -1. All right, -1, bring down the 4. -1 and 4 is -4, -6 is -10. That would make a +10, and a -7 would be a +3. That'd make a -3 and a 9 would be a +6. That'd make a -6 and a 2. That'd be a -4. So we have an ordered pair at -1, -4. So at -1, we're down here at -4. Alright, so we have crossed the axis somewhere because we've gone from 0, 2 to -4, 1, -4. So we have come down somewhere. Alright, let's try, that's not our lower bound because we're not alternating. So let's try -2. Bring down the 4, that's -8, and -6 will be -14. That's +28, and -7 would be +21. That's a -42 and 9. -42 and 9 would be a -33. And a +66 and 2 would be a +68. This looks like our lower bound. Positive, negative, positive, negative, positive. So -2 is our lower bound. So at -2, we're way up at +68. So our graph must come through, and we have a point there, so it's got to come through somewhere in here like this. So our graph might look something like this. We could be off, we can't see everything about this, but that would give us an idea of the shape of our graph, and we've also located our lower and upper bound. Now that makes sense because it's a positive. We knew it had to go up on the right. It's a even, it had to go up on the left. That makes sense to us. Also, just so you know that we could have up to 3 turns or 1 turn. And so maybe we just have this little 1 turn down here, or we have actually a turn here and a turn here and a turn here. So there would be our 3 turns. Again, this doesn't tell us everything, but it tells us a lot. Whenever we have a sign change, when it goes from negative to positive, that's when you cross the x-axis. That's why we know up here we stayed all above the x-axis and just kind of rambled around. Alright, hope that's a little interesting for you on a lower and upper bound chart. You really need to be able to do your chart and identify which value is your lower and upper bound. Alright, have a good evening. Hope everything's going well. Hope good luck on your test tomorrow. If it's Monday night, if it's Sunday night and you're watching this, then see you in class tomorrow. Have a good evening and go Bearcats!